Welcome back to Math Mini Lessons. In this lesson, we're going to look at patterns in tables and graphs. So here are the things to look out for. 1, watch how we describe the patterns from a graph that describes the relationship between the two variables. Also, look out for how we can accurately complete a table of inputs and outputs when given an equation, and how we can use some of our substitution for x and y to create coordinate pairs if we don't have a graph itself. If we have a graph, we'll just be able to see it there. And also look to see how we can describe that relationship between the x and y in the context of the problem, and we can use that to accurately compare the rates. Here's our first problem. Ryan is running on a treadmill. The graph below shows the proportional relationship between the time he has run and his distance. What is Ryan's speed as a unit rate? So because they're asking what is the unit rate, they really mean how fast does Ryan run every single minute. And because this is proportional, we know that this means that it's a constant rate. And we can see it on the graph. You can see that it is just a constant rate between the speed and the distance. So this tells us a few things. 1, we know there's some type of relationship between distance and time. Those are two variables. Because the graph is linear with a constant speed and starts at 0, 0, there's a proportional relationship. So this goes back to 7th grade math when we talked about proportional relationships. So that's just another thing to note. It starts at the origin and it's a straight line, so it is proportional. And that's important because it means we can represent this using the y equals kx equation. That's going to be super helpful for our plan. And here's what it is. I'm going to use a set of points to create an equation that describes that relationship between speed and distance. And the equation I'm going to use is y equals kx. And then I'm going to use the equation to find that k, that unit rate. So I'm solving for k, and then I'm going to check my work by using 2 additional coordinates to see if I'm getting the same answers for k, if I'm getting accurate equations and solutions. Okay, so let's hit pause so you can jot this plan down, and we'll put it into action. So I've already written our equation for y equals kx, and what I'm going to do is let's just look at our graph and identify some coordinates. And I'm looking for coordinates that are pretty easy to just recognize and see. And we have 10, 1, we have 22, and we're going to use 33. So I can use any of those points on the line for this. So I'm going to start with the easiest one, the first one, 10, 1, and I'm just going to substitute it right into y equals kx. Okay, so I'm going to put when y is 1, I have k times 10. I'm going to isolate k. So 1, this can look like this, like 10k. So I'm going to divide both sides by 10. And this means k is equal to 1/10. So let's check and see if that's true if I try a second coordinate. So let's try 20 and 2. So 2 is equal to k times 20. 2 is equal to 20k. I'm just writing it the same way we've always gotten used to it with a coefficient. I'm going to divide both by 20. And I get 2 over 20, which does simplify to 1/10. So I am getting a constant k. So let's try something for the third one just to truly verify this. I'm going to put all the points in. So let's use 30 and 3. So 3 is equal to 1/10 times 30. So let's see if this is true. I'm going to just put a 1 underneath here. And I'm getting 3 is equal to 30 over 10. And yeah, that is true. 3 is equal to 3. So this is valid. So my k is equal to 1/10. And what does that 1/10 actually mean? Let's put this into context. This means that Ryan's speed is 1/10 miles per minute. All right, that's it in context. It's telling me how fast he runs over a unit of time per 1 minute. And why did I want 1 minute? Because we were looking for the unit rate. All right, so let's hit pause so we can jot this plan down into our notes. Now that we know how to find a rate using a graph, let's actually put into practice in this problem. Charles needs to fill a large fish tank with water using a hose. He has 2 hoses from which to choose. Water flows through each hose at a constant rate. The graph below shows the amount of water of gallons that flows through hose A based on the number of minutes used. So yeah, that always makes me chuckle too. Hose A reminds me of my brother. So I can see over here, we can recognize there's a constant rate starting at 0, 0, so it is proportional. So we have this information over here. Let's see what else we have. A total of 110 gallons of water can flow through hose B in 10 minutes. Which hose has a faster water flow rate in gallons per minute, and what is the rate? All right, so we're really going to compare A to B. We're going to look at the rates for A and the rates for B to figure out which one is greater. So let's start using our equation y equals kx for our graph, and I'm going to look for some points. So even though I see 1 minute here is somewhere between 4 and 8, I want to make sure that I'm getting a really accurate number. So I'm going to use this point instead, 212. So let's substitute those in. So I'm going to put in 12 for y and k times 2. Let's rewrite that. 12 is equal to 2k. And now I can just simplify this by dividing by 2. So k is equal to 6. So 6 what? What does the 6 represent? For Jose has a rate of 6 gallons per minute. That's our unit rate for this first one. Let's go into our second part for hose B, and here we just know it's 110 gallons in 10 minutes. So I'm going to do the same thing, y equals kx, and I'm going to put 110 here for y, and y because that was the amount of water over here, so same y, and our x is going to be time. So k times 10 minutes. Let's rewrite that. 110 is equal to 10 times k. Divide both by 10. And in this hose, k is equal to 11. Hose B has a rate of 11 gallons per minute. So one thing I want you to note, look at how we can figure out what the constant rate is, whether we have a graph or if we're just given enough information, because we can substitute those values into our equation. All right, so let's do our comparison. So which one is obviously greater? Hose B has a greater rate because it has a rate of 11 gallons per minute. Hose B has the greater, actually let's use the word faster. Faster flow rate. All right, so that's our second example. Remember, the reason we're using our equation y equals kx is because this is a proportional relationship, meaning there's a constant rate and it begins at 0, 0. That is why we're using the equation y equals kx and not using the equation y equals mx plus b. All right, so that's it for today's lesson. It did touch upon some of our 7th grade proportional skills, but sometimes we just need a little bit of a refresher, and we can use our algebra skills to solve the problem. That's it for today's lesson, Math Marvels. Be well.